Hi, imagine this. A customer calls about noise coming from the heating system. You head out, and upon arrival, you hear it loud and clear. But where in the system is it coming from? There are multiple potential sources of noise, and as hydronic systems easily transport the sound and vibrations, it can be difficult to identify the source. The good news is that this challenge in most cases can be solved. Let's see in the Grundfos lab. As noise easily gets transmitted via structures and components in the heating system, it's very difficult to remove. This small music box illustrates a pump. When I play in the air, you can barely hear anything. But when I place it on this radiator, for instance, the noise becomes much louder. There are many causes of noise in heating systems. Two main causes are incorrect dimensioning and incorrect commissioning. If the pipes are incorrectly dimensioned to the required flow, high flow velocities may generate noise in the pipes and valves. To prevent flow-related noise, you must size pipework correctly and avoid abrupt changes of pipe dimension, sharp edges, and tight bends. An example of this is when you're replacing an old boiler with a new heat pump. A heat pump installation typically requires significantly more flow than a boiler due to the lower temperature. Proper configuration, correct speed setting of the pump, and careful balancing of the system is also essential. If this is not done correctly, velocity noises can occur in thermostatic or ordinary radiator valves. To prevent noise from the pump itself, Grundfos circulators are tested in Grundfos's own sound laboratory. Let's go and have a look in the lab. Here in the sound lab, the circulators undergo very comprehensive noise tests with focus on the noise emitted through air, water, and the piping structure. The setup with the 20-microphone hemisphere allows us to measure and document the general noise level. Extra vibration and fluid sensors are used to quantify the noise emitted from the pump through the piping system. The binaural hats allow us to record and design the circulator sound. The acoustic camera with more than 100 microphones is another strong tool that makes it possible to see the noise of a pump down to the smallest detail. But no matter how well tested those components are, it's impossible to fully replicate the diversity of real-world installations. This means you as an installer play a crucial role in designing, dimensioning, and commissioning heating systems correctly. This all means that when the system is running quietly, it's running optimally, and that the homeowner can save energy and enjoy a more comfortable, well-heated home. See you next time at the Grundfos Lab.